In this video, we're going to have a look at how do we identify an outlier within our data set. So by the end of the video, you will be able to identify any outliers using calculations. Then you'll be able to also explain the impact of an outlier on the measures of center and the measures of spread. So when we're looking at outliers, what we are looking for are extreme values at either end of the data set. Now those extreme values are going to be different to the rest of the values in that data set. So it may be that it is an extremely large or an extremely small value compared to the other numbers in the data set. So if I had my data set on the screen, and we can see we've got 21, 22, 23, 23, 23, 25, 26, 28, 30, 32, 34, 34, 35, all of those numbers are fairly close together. There's no big gaps in those numbers. Then if I had a number on the end of 83, I can see that 83, there is a big difference between 35 and 83. So that 83 is going to be an outlier. So sometimes it'll be really obvious when you're looking at it that a number is an outlier, like our 83 compared to our next number of 35. Other times it won't be as obvious. So what we can do is if we are looking for outliers, we can calculate using the interquartile range and quartile 1 and quartile 3 values as to what is going to be our lower fence and what is our upper fence. Now these fences are the boundaries for which we use when we're calculating outliers. So after we've done our calculations, if we've got a number smaller than the lower fence, it is going to be an outlier. If we have a number bigger than the upper fence, it is also going to be an outlier. So our fence calculations, our lower fence is going to be quartile 1 minus 1.5 times the interquartile range. And our upper fence is going to be quartile 3 plus 1.5 times our interquartile range. So we can use those calculations to be able to identify an outlier in a data set. So let's have a look at an example. So in my example, we've got data that represents the car sales each month at a car yard. And we've got 12, 9, 15, 10, 11, 23, 14, 8, 6, 11, and 13. And we want to calculate the lower and upper fence and identify any outliers. So to be able to complete the calculations, I need to know what's my quartile 1 value, what's my quartile 3 value, and what is my interquartile range. So if you're not sure on how to calculate these, go back and have a look at the videos on measures of spread, and it will be able to help you complete those calculations. But now we'll quickly go through how we would do those calculations. But if you need more information, go back and watch that measure of spread video. So starting off by arranging my numbers into ascending order. Once I've arranged my numbers into ascending order, I need to split them into halves. So all up, I've got 11 numbers. 11 plus 1 divided by 2 is 6. So my middle number is going to be my 6th term. And because it is a term in my data set, I cross it out and remove it. And then I'm left with 2 halves, each consisting of 5 numbers. So looking at the first half, finding the middle of the first half, it is going to be 5 plus 1 divided by 2. So it's going to be my 3rd term from the beginning of the half. So the 3rd term from the beginning of the half is going to be 9. So my quartile 1 value is 9. Starting from the second half, my 3rd value is going to be 14. So my quartile 3 value is 14. So that means my interquartile range is going to be 14 minus 9, which is 5. So what I can do is use those values now to calculate my lower and my upper fence. So my lower fence is going to be my quartile 1 value minus 1.5 times my interquartile range. So substituting in my values, it's going to be 9 minus 1.5 times 5. So that is going to be 1.5. So my lower fence is 1.5. My upper fence is going to be quartile 3 plus 1.5 times my interquartile range. So my upper fence is going to be quartile 3 plus 1.5 times my interquartile range. So it is going to be 14 plus 1.5 times 5. Once I've substituted in my values, which is going to be 21.5. So I've got a lower fence of 1.5 and an upper fence of 21.5. If I've got any numbers beyond those numbers, either below 1.5 or above 21.5, they're going to be outliers. So the first number in my data set is 6, which is higher than 1.5. So I don't have any small outliers. My last number is 23, which is above 21.5. So that 23 value is going to be an outlier. So in my data set, I've got one outlier of 23. So when we have outliers, it is going to impact on our calculations for both measures of spread and measures of center. When we're looking at our measures of center, if we've got a low outlier, that is going to decrease the mean. Those low numbers are going to bring the average down. So while it decreases the mean, there's going to be no significant impact on the median. If I've got a high outlier, what it's going to do is actually increase the mean. So make the average higher, but it's going to have no impact on the median. So because we can see when we've got outliers, our mean or our average is impacted, but there's no significant impact onto the median. When we have an outlier in the data set, the median is going to be the better measure of center. So you can still calculate the mean, but if you're looking for a measure of center, the most accurate one to use is median when you have an outlier. When we have a measure of spread and we have outliers in the data set, the better measure of spread is going to be the interquartile range. Because those outliers are going to impact on the range, we are going to use interquartile range to measure our spread. So if we're looking at consistency, when we have an outlier, look for interquartile range instead of range. So that's some examples of how do we calculate an outlier, and then what are the impacts on our measures of center and measures of spread when we have an outlier.